So compounds, well, let's see. Let's start with the elements. Elements can be atomic or molecular. So we've talked about pure substances being divided into elements or compounds. For the elements, some of them are atomic, meaning the smallest particles are individual atoms, and some elements are molecular, meaning that two atoms of that same element, oxygen, form a covalent bond with each other, and there are discrete molecules. When we talk about compounds, these can be either molecular, where they're sharing electrons, or they can be ionic, where they've transferred electrons and formed ions. So the smallest particle in a molecular compound is a molecule. The smallest particle in an ionic compound is an ion. Okay, so these names are descriptive of the substances. So most elements are atomic elements. In their pure state, the individual particles are atoms. So here's some examples. Most of the elements on the periodic table are that way. Molecular elements exist as molecules, two or more atoms of that same element bonded together. There are 7 that form diatomic elements, and these are ones we need to know, these guys. Phosphorus and sulfur are also polyatomic elements. You should just be aware that they are, but I'm not gonna test you on them. Phosphorus tends to form molecules with 4 atoms, and sulfur forms molecules with 8. And both of these have different forms of these molecules. So here are the molecular elements. In the yellow are the ones we need to know: nitrogen, oxygen, fluorine, chlorine, bromine, iodine, plus hydrogen. So do I have this? No, I got to write it on here. So how do you remember these? Because this is important. You need to have these 7 and be able to pick them out. Well, I think it's kind of cool that if you start with element number 7, nitrogen, and you make a 7, that's most of them. And then hydrogen, of course, has to be the exception to everything. He's over on the side by himself. So that's one way to remember. Another way is Brinkelhoff. Oh, I left one out. Yeah, maybe that's not the best way. There's Brinkelhoff. But the one I usually use is a silly sentence. Horses need oats for clear brown eyes. Horses need oats for clear brown. It's all great until you get to the eyes. Yeah, somebody made another one out that was kind of clever, and it involved beer. And so they liked it a lot, but I can't remember it. Something about ice cold beer, yeah. Have no fear of ice cold beer. That's it.
And it had the eye, so it was...
Yes, it did. So it did have the eye in it. Have no fear of ice cold beer. So that's another one. But it's the first letter or two here: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So chlorine is Cl, bromine is Br. You need to know those, okay? And then these guys in here, phosphorus, sulfur, and selenium, they also form polyatomic molecules. Polyatomic meaning more than 2. But these 7 are the diatomic ones. They're always molecules of 2 atoms. So molecular compounds have molecular bonds. They're composed of 2 or more covalently bonded nonmetals. There are no metal elements in molecular compounds in this class. So the basic units are molecules, such as water, H2O molecules. Dry ice is CO2 molecules. Propane, which you may have in a canister like this on your back patio, is C3H8. And so looking at the individual particles in there, these are the space-filling models, has 3 carbons and 8 hydrogens. They are discrete units. They stay together, but if you change it from a liquid into a gas, the individual molecules get away from each other, but they stay intact. If you freeze them, they come together and they get stuck in a lattice, but they're just still their individual molecules. Ionic compounds, you have to have a cation and an anion. The cation is almost always a metal. There's only one exception that we're going to use. So I'll just tell you the truth that I'm going to lie to you about some things. There are some things that are just beyond the scope of the class, and so we kind of have to ignore them. And so we're going to say that NH4 plus, do you remember that from that list of things you're supposed to memorize? Ammonium. That is the only polyatomic non-metal cation that we're going to deal with. So that's the only one. All the other cations are going to be metal cations. So ionic compounds are going to be a metal and one or more nonmetals. They're held together by ionic bonds. This is the one exception to it having to contain a metal. The basic unit of the ionic compound is not a molecule, because a molecule is atoms covalently bonded together. And that's not what happens in an ionic substance. In an ionic substance, you have cations and anions, and they arrange themselves in a lattice. And this whole salt crystal, by the way, have you ever really looked at table salt? And it's these perfect little cubes. Do you think that Morton Salt Company puts a lot of effort into making those into cubes? Nope, they do not. That is the way that sodium chloride naturally forms. It forms little crystals like that, and they tend to be cubes. They're going to have right angles. So in a sense, each of these is just one giant lattice of alternating cations and anions. So how can you say what a molecule is? It's not like propane, where these are covalently bonded together and they are not attached to each other in any way. There's no long-range order here. There's individual molecules. Here we have a series of alternating cations and anions. There is no molecule. We could write the formula for a single salt crystal. We could do that, but the numbers would be ginormous, right? Because in any substance that's large enough for you to see with your eye, it's going to have a gazillion different atoms in it, right? So that's not very useful. And each of these crystals would have a different formula, so that's not very useful. So what we do is we use what's essentially the empirical formula for an ionic compound. It's the lowest ratio. So we talk about a formula unit, which is the smallest electrically neutral collection of ions. So what's the smallest number of sodium and chloride ions that you could have and have it be neutral? One of each, right? If you had one sodium and one chloride, they could combine with each other and make sodium chloride. You wouldn't have to have more. That's the smallest you could have. So we call that a formula unit. It is the unit based on what the formula is. The formula gives us the lowest ratio of cations to anions to be electrically neutral. Any questions? There is a question on one of the labs, a post-lab question, about ionic compounds and finding molecular formulas for them. Are there molecules in an ionic compound? Are there molecules? What's the molecule? There's no molecules. It's just a series of cations and anions. There's a formula unit, and we identify the formula unit as the lowest ratio, the smallest number of each that gives us an electrically neutral collection. but the actual piece of matter is just going to be a multiple of that. They're not discrete molecules in ionic compounds. There are ions that involve covalently bonded atoms. So a cluster of covalently bonded atoms, but overall they either have an extra electron or two, or they're missing some electrons, and so they have a charge. We call these polyatomic ions. It's an ion, it's got a charge. Polyatomic means many atoms. And these were on that list that I made you memorize, right? So if we look at this ionic compound, NaNO3, this has a sodium ion and a nitrate ion. So there are two ions, but this ion happens to have two different elements in it. Calcium carbonate, we've got calcium ions and carbonate ions. We can predict the charge on sodium and calcium and potassium based on their position in the periodic table. We know the charges on these because we memorize them. That's why I made you memorize them. This compound, KClO. So there's a potassium ion and a hypochlorite ion. In this class, ionic compounds will always have two ions, one cation, one anion. You'll go beyond here and you'll find out that actually some do have two or three cations. It's possible. But we're completely ignoring those. So we're just two ions, okay? And we'll talk about these a little bit later. It is important to be able to classify substances. We're going to be learning how to name substances, and in order to do that, we have to identify which system of rules we're going to use. So we need to identify what kind of compound these are, what kind of substances. So there are atomic elements and molecular elements. There are molecular compounds and there are ionic compounds. So let's look at each of these. So here's the name, fluorine. First of all, is that an element or a compound? That's an element. And here's a tip. Most compounds have two names, just like most people go by two names. But some compounds do have a single name. Examples are water and ammonia. But usually if you see a single word, that's going to be an element. So fluorine's an element. What kind? Is it atomic or molecular? It's molecular. It's one of those 7. Horses need oats for clear brown eyes, or have no fear of ice-cold beer. If I say that enough, I'll remember it. So this is a molecular element. So if we're going to write the formula for fluorine, it would be F2. It's a diatomic element. So this one, N2O, is this a compound or an element? It's a compound. When we look at the formula, there are 2 different capital letters. Each capital letter means it's a different element. If you got more than one element, it can't be an element, it's got to be a compound. So then we have to decide, is this molecular or ionic? And what we need to do is look at the first element and ask ourselves, is it a metal or a nonmetal? Somebody tell me. Nonmetal. How do we know that? Position on the periodic table. Remember the stair-step line? Above and to the right of the stair-step line, those are nonmetals. What about the metalloids? Well, we're going to go with what side of the line it's on. So if it's on the nonmetal side, even though we recognize it's a nonmetal, for these purposes, we're going to call it a nonmetal. Okay, so we've got a nonmetal and a nonmetal, and so this is going to be a molecular compound. So molecular compound. I don't feel like writing out all those words. Any questions? How about this one, silver? That's an element. Molecular or atomic? Atomic. It's not one of the 7. So that's an atomic element. K2O. This formula is a lot like N2O, right? So this is a compound because there's more than one element in there. Look at the first element, K, potassium. Now, from everyday life, I would not expect you to recognize that potassium is a metal. So don't rely on that. Oh, I've never seen, a sheet of potassium metal. No, you wouldn't, because it reacts violently with water. So it's just not going to be very stable. We're going to look at the periodic table and see, where do we find capital K on the periodic table? It's to the left of the line. It's a metal. Here we have a metal and a nonmetal, ionic, or ic. How about FeO3, Fe2O3, sorry. It's obviously a compound, two different elements. Find Fe on the periodic table. Is it a metal? Yeah. So it's a metal, so this is ionic. Ionic compound. So if it's got a metal in it, that first one is metal, it's ionic. If you've got only nonmetals, then it's going to be molecular. Any questions? That's the first step in nomenclature, being able to identify the different kinds.